Okay, so, hey, when dealing with graphing in 9.4 here, using the form y equals a sine b theta, that's what we're going to be using. That form we're going to be using a lot. We're going to be changing the trig value in there, whether it be sine, cosine, or tangent. But yesterday when you did these graphs, these are Andrew's graphs. Thank you, Andrew. Okay, you went through, you graphed y equals sine x, y equals 2 sine x, and then
Sine 2x.
sine 2x, and then 2 sine x there. Okay, and you'll notice the different changes there. And then the questions on the back says, how does a change the graph of sine x? So when we're looking at the form of y equals a sine b theta, how does a change our graph? Well, what does it look like it does? We change that number in front of sine. Go ahead.
I said it changes the amplitude of the graph.
Good. It changes the amplitude of the graph. It makes it go up higher or go down lower. How does b change our graph? Here?
B affects the period of the function.
Good. B affects the period. Okay, it affects the period. In fact, the number of times you see it, I heard some students talking yesterday, the number of kind of bumps you see in it. Okay? We're going to see that in the next part here as well. So we're going to kind of play around with that function. Okay? So let's go ahead and turn to the other side of your note page there. Right here. Copy and use your calculator. Complete the table below. A few things you need to know in order to do this. You need to know that period, what period and the number of cycles equal. Okay? Actually, I guess you don't need that quite yet. So actually, why don't we go ahead and do this table first. Okay? Go ahead and go to your window. 0, 2 pi, pi over 8, -4, 4, 1. Set your window to those settings. Make sure you are in radians, in the radian mode of your calculator.
Yeah, it doesn't graph. Which one's
Huh? No, I want you to go to radians. Yep. Okay, here you go. Put those in. Hey, can I have your attention back up here? Hey, my fault. Theta is x. So on your calculator, when you look at your calculator, this button right here that we usually push for x, you'll notice it says t and then theta. So it's the same. It'll actually show up as x on your calculator when you push it. Okay? But you're going to be, your y equals menu, you're going to be setting your first graph. It's going to be sine of x. Okay? And then, let me turn off that light so we don't get that glare. Make sure we can still see it. You see it now?
Yeah.
Yeah? Okay. Okay, y equals sine x. And then, if you haven't changed your window yet, make sure you change it to those settings. So, it's like we had 0. I haven't changed mine. So 0, you just hit enter, 2 pi, pi over 8, -4, 4, uno and uno. And then make sure your mode is in radians. And then when you graph it, you're able to fill in some of your table now, right? So we get a cool little picture, all right? And, oh, isn't that cute? Was that someone's calculator or phone? That was a
syntax error.
Yeah.
Wait,
Yeah,
should make that noise?
Shouldn't be a syntax error, I'm hoping.
It should. No, like, because I grabbed all of them at one time.
Oh, yeah, try to just turn one graph on at a time. What is our amplitude on this one? It's hard to tell. You guys remember when we just went through and set our window? We need to, we need to know what our y max and min are. We had 4 and -4, so we need to know what these values meant up here. And so going back to our graph, it looks like we're going up by 1 on the y-axis. So we went from 1 to -1, so our amplitude is
1.
1. It's half of the distance from max to min. Number of cycles, how many times?
1 times.
1 cycle. And the period, the length of 1 cycle is? Well, once again,
360.
so some of you aren't paying attention here.
2 pi.
So, once again, you need to know what the scale is. So, if you're looking back at your window, remember we went 0 for our y minimum. Our maximum was 2 pi. It changed it to 6.28. Okay? And then we went up by pi over 8. So when we're looking at our graph, that's going from 0 to 2 pi. That was the length of 1 cycle. So a period is
2 pi.
2 pi. Okay. Now please remember, this brings up a good time to point this out. Period is equal to 2 pi divided by something. And b is equal to, our b term, when we're thinking of the equation y equals a sine b theta. B is equal to 2 pi over something as well. We're going to be filling in those somethings. Okay, maybe get that filled in as you're filling out your table. Okay, here we go. Go ahead and finish that up. Okay, as you get them done, let's get them filled in up here.
So for sine x, what would the
For sine x, it's going to be 2 pi. Because you're not changing b term at all.
Because you're changing the period.
Oh yeah. Oh. Because it just goes
One
to
row is filled in.
or sorry.
Only can do
Oh my
one
gosh,
row
this doesn't
per.
make sense. Like
Still one. Number of cycles.
because
So
when you have 1 cycle, it's gonna be 360.
oh, dude, I figured out. So the
Oh my gosh.
B term.
So for 4 stars,
I get it now. So that
You should probably use pencil.
for these, they're all good.
Oh, yeah, my turn.
I got this one. That's your pencil.
I got sign 4.
No, I got this one. Oh wait, no, that's
I landed it.
Dang it, Ben. Move faster.
yeah, almost wrote 2 pi over 4.
Dude, that would be exactly the same.
But it's not the same.
It is the same.
It is close to the same.
Oh, I was just gonna write all of the B ones.
No.
Okay, I did my row.
it's 4, right? Yeah. So then it's still 2 pi? Yeah.
Riley, your pi is
The last 5 or 2 pi.
Hi, you made it with this.
Jada. So, wait, can you split it?
Alright, let's get the rest of them in.
Wait, so the amplitude is
Okay.
Oh, the amplitude is the absolute value of it.
Yeah.
yeah, because there's no, you can't have negatives.
Right. You can't have
Okay, and then we
negative.
have
That's the secret. I think I'm much don't say it out loud.
I think I filled out the graph completely.
Period. How do we figure out?
Oh,
the
do
period?
it. Fill it out for the bus.
Okay, yeah.
I'm gonna plow your
2 pi.
bus.
Well, how do you figure out all the periods?
So if it was negative sign, is that a 1? I don't know what
Yeah.
I wrote.
Pi.
2 pi over b. I already told you that, and you're like, okay, you use your fancy math. I'm just gonna.
No, you said that it was too complicated. Wait, does that mean the number of cycles is 2 pi over 8?
No. Wait.
Fine.
Number of cycles is 2 pi. Not anything at all. Number of cycles is b. Just as b. B equals b.
D equals graph.
Okay. Oh, I get it. The number of cycles is 2 pi.
No.
No, it's 2 cycles.
No.
Okay, what's the
It says
answer?
it's 2 pi over something.
No.
If it's
Cycles
wrong, I
is
hate
not-
you.
It's 2 pi over 2 pi times b. Right.
All right. Hey, well done. Hey, let's see now. If I can get your attention back up here. Hey, taking a look at that at the top, period. P equals 2 pi over, and number of cycles, B equals 2 pi over. I want you guys to fill that out if you haven't done so already. The group.
Mr. McCoy, isn't the number of cycles just 2 pi over 2 pi times b?
Don't know.
I think it is.
Could be.
That'd be like saying.
What does your
Exactly.
groupie say?
What's that?
What do your groupies say?
What do you say, groupies? I
I
think
say this.
What are we answering?
I see.
Oh, about the.
This is the fun
we're
one.
answering the top ones. I know the
It makes
period is
eyeballs.
2 pi over b.
That's what it would be about.
2 pi
But
over
I
b.
think for the number of cycles, I think it's 2 pi over 2 pi times b.
Would it be over a? Yeah, that would be just b. No,
A.
it's number of cycles b equals b.
No. Because if you
2 pi over.
okay, yeah, no, it would be
Oh, it's 2 pi over p.
2 pi over a.
P.
Not over P.
It's over p.
It's not. It's over b.
It's over p.
Because this would
Wait, hang on.
It's 2 pi over p because 1, 2. Yeah, see, thank you.
Okay, wrap up talk.
2 pi over p,
Wrap up the discussion here.
which is the same thing as 2 pi over 2 pi.
Okay, period. Period is always equal to 2 pi over what? How many say A? I heard A. How many say B? How many say something else? Yes, 2 pi over B. You'll notice if you divide, to find P, if you divide 2 pi by B, you always get that. This would be 2 pi over 4, which is pi over 2. Okay? So 2 pi over B. The number of cycles B, so if we just solve this equation for B, we could do that. We could just multiply both sides by B and then divide by P. This is 2 pi over P. So if we want to find this, we could divide 2 pi by that. 2 pi divided by 2 pi is 1. 2 pi divided by 3 is 2 pi. Okay? Yeah. Go ahead.
Isn't it just, couldn't the number of cycles also just be p?
The number of cycles.
Yeah,
You're
it's
saying
just
b equals b.
b equals b.
Yes, b equals
Yeah.
How do you find
q.
How do you?
equals q.
Hey,
It's right there.
hey guys, it's a good question. Couldn't the number of cycles is B? Okay, we're saying if you don't know what B is, but you know the period, you divide the 2 pi by the period. Okay, B stands for the number of cycles. Listen up. B is the number of cycles between 0 and 2 pi. So when we're looking at our equation here, A is our amplitude. Okay? B is the number of cycles. Make sure you add to that from 0 to 2 pi. Okay, it's not the number of cycles that you see because your graph may go out to 8 pi. It's the number of cycles there are between 0 and 2 pi. So that's why we find B by dividing 2 pi by the period, by the length of one of those cycles. Okay, we're going to see that here in a minute when we graph. Okay. Questions? Okay, let's try this. Hey, there's all the answers, by the way. You guys put them in. All right, let's write some equations first. Okay? Everyone give number 1 a go. You guys get about 30 seconds. We're going to pick up the pace a bit. Yep.
Amperage is 4. Y equals 4 sine.
Those of you struggling starting, use your standard form. Oops. I just messed up on my standard form.
Oh my goodness.
Unbelievable. That should be B.
2 pi over 2 is 1. So that means nailed it. Son of a gun. That should be right.
It's not a sine 2 theta, a sine b theta.
Y equals 4 sine x.
Okay, here we go. Number 1, y equals, if we go a sine b theta, what's a?
4.
Or what's b?
1.
Okay, this is where we need to use that formula we came up with. B is the number of cycles between from 0 to 2 pi, right? So to find b, we divide 2 pi by p. So in this case, the period is 2 pi, so 2 pi divided by 2 pi is 1. Okay, so this is 1, b is 1, theta. Now, usually we don't show the 1. Okay, we don't write it like that. We usually write it as 4 sine theta. Okay, so if you don't see a b term, it's 1. All right, everyone give number 2 a go.
Because you divide.
Okay, y equals 1.5 sine b.
4.
Well, that's not b, right? That's p. So how do we find that out?
2 pi over
Well,
2 pi divided by pi over 2.
good, yeah. Once again, b is equal to 2 pi over p. So that's 2 pi over 2. For those of you that don't know how to do that, okay, that's compound fraction. That really means 2 pi divided by pi over 2, which is the same thing as 2 pi times 2 over pi. Pi's cancel, so we get 4. B is 4. Now, that's the algebraic way. Go ahead.
I don't understand how we know like that A is the amplitude, because if you have a negative, like if A is negative, the amplitude will still be positive.
Well, yeah,
Uh,
it's absolute value.
Yeah, it's the that's
When it starts below the graph.
hey, good point. If A is negative, that just means rather than our sine curve, we'll see this today. That's a good point. If I have a sine curve, if A is negative, it just means my graph, rather than going this way to begin with, that's a positive start. It's going to go down to begin with. Okay, but our amplitude, you're dealing with absolute value.
Yeah, I know. So like, how do we know that? Like then it would be like plus or minus for the A, because
No, the negative sign in front will just tell you you're starting downward.
isn't that like change the whole thing?
What's that?
Isn't that like change the whole thing?
It doesn't change the whole thing, no. Because we're going to see it when we graph it, but if we put a negative sign out here, yeah, it's not going to change anything else in here. It's not going to affect this. This sign of whatever it's a compact math problem. There's like implied parentheses right here. So you're doing all this, and then you're multiplying by whatever A is. And so when you multiply by that as a positive, it's going to make it go upward. When you multiply by that as a negative, it's going to make your values become negative, and they're going to start going downward.
Because it's kind of like the exact opposite, because like the graph is going down at the start, and so that it's the opposite of when it was going up. So it doesn't change the values except the positive and negative. It's just like change how you see it. You know, it's different. It's a different graph.
Can we wait until we graph it? Maybe I'm not following what you're saying here. There you go. I understand that can be confusing with negative, but let's wait until we graph them, because I think you're going to see it then. All right? Or if you think back, look at your graph from yesterday. Put a -1 in front of it, and see it'll just flip those graphs around, those values around. Okay? I'm not sure I exactly understand what you're asking here then.
It just could be a different graph. Like it's the exact opposite. All the values are the exact opposite.
Yes.
Exactly.
So how do you know that it could be positive or negative when the values completely change?
Math.
Exactly opposite.
Okay, why don't you and I talk about it? So you're right. So what? Okay, if I understand what you're asking, when you're looking at this, this is the positive value. Okay, that means your graph is doing this. It's going upward. All right, and it's an ugly sine curve. Okay, but if I change this to y equals negative a sine b theta, that's just reflecting all these points. That negative sign. So it means you're now going downward.
Yeah,
Do we agree on that?
yeah.
Okay. So what's the question?
Well, like, then it could be, so it could either be the top one or the bottom one.
No. The negative is going to tell you. The negative is going to tell you it's going down first. The
Yeah.
positive is going to tell you it's going upward
No,
first.
so you can't derive that from the amplitude, because the amplitude is the absolute value of A.
Oh, so what you're saying is that you're saying that this equation should say plus or minus.
Yeah, it could be,
It could be either one. Okay.
Yeah, how do you know?
Okay. I understand what you're asking then.
How do you know?
So from this equation, need your attention here. Hey, from this equation, you could have positive 1.5 sine 4 theta, or you could have negative 1.5 sine 4 theta, based on what they've given you. Okay? So that's what you're saying. It's not that the graphs are the same. Okay. Yeah, that's fine. If you want to put this, that would work as well. All right? Yeah.
How do you know whether it's going to be positive or negative once you're graphing? Because
Once you're graphing, how do you know? They're going to give you an equation. They're going to tell you what to graph. You could put plus or minus, sure. When you're writing the equation given these two pieces. No, I'm fine with you putting plus or minus. I'm fine with you just putting positive or negative. Okay? Either one would work. All right. Hey, you guys, we were having that conversation. The hard thing as a teacher is to know when to cut someone off. And the reason I have to start cutting people off is because, like, I had talking from one part, I had Justin practically on the ground and Maddie kind of slouching your seat. You guys, I need you focused. So those of you who missed that conversation, you just missed out on a major piece of conceptual understanding. All right? Stay focused. It makes it easier to actually discuss things when I'm not having to worry about trying to do classroom management in other parts of the room. All right? Okay. So, number 3. So either any of these could be plus or minus. That was the point. Okay? So we can make this positive, negative as well. Either way. All right? Hey, number 3, amplitude is 2. So y equals 2 sine. What's b?
6.58.
What's that?
I think it's 6.58. Did you divide it by 3/3?
Yep, you got to divide it by 3 pi.
Oh, duh, 2/3. Sorry.
Yeah. So b is equal to 2 pi over 3 pi, or 2/3. Hey guys, let's make sure we understand what this means. If I go back to this picture, and I'm just going to focus on the positive one now. If I were to draw this picture, this would mean I'd see 4 cycles of this graph from 0 to 2 pi. So 1, 2, 3, and 4. Right? Not amazing, but we've got 1 cycle, 2 cycles, 3 cycles, and our 4th cycle. All right? So this would have to be 2 pi right there. This right here, this is half of 1.5, or excuse me, not half of it. This length from here to here is 1.5, so from here to here is how far?
3.
3, so that's 1.5, and that's negative 1.5. Are we good on that? So that's what we're looking at. So I want you to go ahead and fill out 4, 5, and 6. Okay, write your equation. Yep, and as we talked about, this could be a plus minus. Good. Perfect. pass those out, please.
I got two there. I think there's two there.
What's number 6?
Elizabeth, you pass these out. Huh?
What's number 6?
Oh, number 6.
Amplitude 4, period pi.
And number 6, amplitude 4, period pi. There you go. Okay, if you haven't been up here yet, go ahead and put those answers up. 4, 5, and 6.
Theta. Oh yeah, we need to drop these. Theta. What's up? What's up? Minus. What's up? What's up? Sine. Oh, you did it again. Oh, and theta. Yay.
I was right. I dare you to work your
Oh, what? We have to
Okay, can I get your attention up here? Thank you. Hey, double check. Yeah, we'll put y equals here. All right, good work. So we put plus minus 1/3 theta, plus minus 2.5 2 theta, and plus minus 4 sine 2 theta. How many got them?
I got them.
All right. Well, we're ready to graph then. Let's go on to graphing. Hey, when you're graphing, there's some little things you're going to start trying to remember. Little jingles then. I'll give you one for each pattern we do. Okay? First one is 0 max, 0 min, 0. 0 max, 0 min, 0. Yesterday you graphed by hand. You actually calculated any or every 10 or every degree. Well, every 10 degrees. Okay, today we're going to just calculate these. Okay? So, yeah, I'll help you out. Let's try one. Our sine graph always starts at 0. Okay, unless we start shifting it up or down or left or right. We're not doing that for a while. Okay? So, the parent function of your sine graph starts at 0 and it ends at 0. Okay? So, this one, we're going to sketch one cycle of this curve. This one right here starts at 0. It's going to go up to 1. That's our amplitude. So we went 0. That's our maximum point. And then we're going to go back to
0.
Yep, 0 max, 0. What's our minimum going to be?
Negative 1.
-1. So 0 max, 0 min. And then we go back to 0. So as you do these today, you're going to start saying, what? That's the same thing as my last one. Okay? It's going to be true. Let's go ahead and sketch this. So start curving it. I've actually got to turn the paper here a bit. So, for those of you that have a hard time, you could put a U shape right there. Let me help you out. But these are not pointy graphs. They're curves. Put your arrow on the ends. Okay? They should not look like V's. The other thing I need you to label today, I want you to label your zeros. So, this is 0. This is
0.
What's the length of a period?
Oh.
Oh god. 2 pi.
It's pi, right? They tell us that.
Oh dang.
Which makes this
Pi over 2.
pi over 2.
Dude, Andrew, you're so good at this.
Yeah, aren't you guys?
God. I am God.
Yeah.
Then is the pi at the end there, that's 180?
That's what?
180.
That's 180. Yep. So this says only sketch one cycle, right? So that's why we stopped at pi. Usually it'll say graph this from 0 to 2 pi, which means we'd have to sketch how many more cycles?
One more cycle.
One more cycle.
Oh yeah.
Okay? Questions? How do you think that seems easy? Yeah, I'm hoping so. Okay, let's try this one.
Right.
Number 11. It's off the example side. Which one did we just do off the example?
7.
7. Number 11. I want you to sketch it on your paper. What you think it'll look like.
Darn it.
Yeah, graphs don't look like numbers.
Okay, compare with your neighbor if you haven't done so already.
So neighbor, what you get there?
Okay, what goes here? 0. How high do we go? 1.5. So we'll go up by, we'll say this is 1, so that's 1.5. If you change the scale, that's okay. How do I know I'm going up rather than down to begin with?
Because it's not a negative.
Raise your hand. How do we know? Yeah.
It isn't a negative.
Very good. Paige says it isn't a negative. The A isn't negative. Okay. Okay. Now we'd actually have to see it in an equation because amplitude is a measurement, and that can't be negative, right? Amplitude's always going to be positive. A could be negative. Okay. So I guess if we're going from the discussion we had with Jacob, based on this, we could actually start going downward. Right now, I want to assume we're going upward, though. Okay. All right. No, I want to assume we're going
It
upward.
says 0 max.
Yeah, well, and it says 0 max, but that's something that me and Vogel came up with there. Okay, so here, where do we go next? 0, and then negative 1.5 and 0.
You mean pi root
Good.
3.
It says 0 on the y. The y is not.
Got our curve. What is this?
Pi over 3.
Pi over 3. Now, I've seen some students, they like to label it down here if they want. Okay. I prefer you label it up here so I can actually see. So pi over 3. And this is?
Pi over 6.
Good. For those of you who don't, you just cut the bottom number in half to get half of that. Pi over 6.
Well, you double it.
Yeah, I mean double it, yeah. Okay, cut it in half when you're going the other way.
Cut in half.
Okay, so does it look like your last graph?
Yeah.
Yeah, kind of, but your labels are different. Okay? We got it? All right. Any questions? Hey, tomorrow we dive into it when it's in equation form. Okay, so today, you guys, I like the discussion. I like what Jacob brought up about it. This could actually, based on the information they gave us, if I restarted this graph and saying that's 0, you could actually, based on the amplitude, you could actually go down first. But for us beginning this graph, I'd prefer that you're going to the positive. Okay? All right. I want you to assume our A term is positive, given an amplitude. Amplitude's always going to be positive. That's the difference between A and amplitude. Amplitude's a measurement of distance. It'll always be positive. Okay? So technically, based on this, you could have this or this. All right? But for today, let's always start by going upward. All right. Questions? Okay, your assignment. Take a look at the worksheet. Do not cross anything out today. Your assignment's going to be example side 1 through 14. Okay? There you go.